Okay, so today we will discuss first inclined mirrors, inclined plane mirrors, number of image formation and the technique. Not just number of image, that calculation derivation also we will do, because most of the textbook they just give the formula. So one technique is that technique will do, and also the number of reflections that happens for a ray. So first we'll take that number of image formation inclined mirrors. Inclined mirrors. So suppose two mirrors are inclined like this way. One mirror is like this, another mirror is like this. The angle between them is theta. Okay, and suppose you take a ray. Suppose a ray is coming like this. So all these topics are inclined plane mirror. So this is the first topic to calculate the deviation. Deviation for two reflections. Deviation for two reflection. Okay, so here the ray is coming here, and at this point A, let us call. So here this is the normal. You can draw a normal line here. Normal. So this ray goes in this manner, because here you can take I equal to R. So I, let us say I1, right? Angle of incidence and reflection both are equal. Then this ray again, it is hitting again at this point. Let us call this point B, and let us take again normal here. This normal you may take here like this normal. So this angle you may call it I2, and here again reflection happens, so this is I2. Okay. So there are 2 points of reflections we are taking about. Very interesting questions comes on inclined plane mirrors. Okay. Right. So what we want to calculate? We want to calculate deviation. Deviation. Deviation we want to calculate. Okay. So first of all, we need to understand what is deviation for a single reflection. Suppose if I take a plane mirror, let us take plane mirror, and a ray of light is coming like this. Let us say ray of light comes here, and this point normal is there, and this is the reflected ray. So this is angle I, this is also angle I. If this mirror was not there, then this ray would have gone in this direction, right? But it is turning this way. So this angle, that angle is called deviation. So total angle is 180 degree, right? So I plus deviation becomes 180 degree. So deviation becomes 180 degree minus 2I. So this is the deviation formula due to a single reflection. A single reflection produces this deviation, right? Now here if you see, there are two reflections happening, one here, one here. So there is deviation produced here. If you see the ray of light here, this ray of light was going in this direction, but this mirror has produced a deviation here. That deviation is delta 1, let us write. This deviation is anti-clockwise. Similarly, this mirror, this second reflection, it was going like this, but again there is a deviation here. So this deviation is deviation 2. So we need to add the total deviation. So total deviation is deviation 1 plus deviation 2. And deviation formula we know, 180 minus 2I. Here first I1. So this, then next for this one, 180 minus 2I2. So 180 plus 180 become 360 degree minus 2 I1 plus I2, you can take common. Now what is I1 plus I2, that we need to find out. Okay. So I think all of you know that one important thing, very simple and common important thing it is, right? So what is that? I will tell you simply, without doing much calculation you will find out what is I1 plus I2. So first tell me that suppose if there is a suppose that there is an inclined surface, and if I draw a normal here, if I draw a normal here, and if I draw a vertical line, all of you know that this angle has to be also theta. Why? Because because this is theta, this is 90, this becomes 90 minus theta, and this total is 90 degrees, so this has to be theta, right? This is a normal here, this line is a normal here. Okay, so the idea, this already you have done so many times, mg sin theta, mg cos theta. How did you resolve that? Grade 11 whole you have studied that, right? So the and this concept is angle between two lines is angle between their normals. So these are two lines which is theta, their normal is this yellow color line and red color line. So angle between yellow and red must also be same as theta. Angle between two line is angle between their normals. Okay, same idea, if you see here, angle between these two lines is angle between their normals, and if you see that this normal is this one and this one, so this angle is same angle as theta. Very easily you can figure out this angle as same theta, because this is the vertical and this is the normal to this surface, right? So this is, and in this triangle, now you see in this triangle, now you see this triangle, I think you can look at this triangle now. This angle theta is a exterior angle, so exterior angle is equal to sum of interior opposite angle. That is why theta is equal to I1 plus I2. Directly we can conclude from here, no need for further calculation. So this theta is the exterior angle, I1 I2 are interior angle of this triangle. So we can say that the total deviation formula becomes 360 degree minus 2 theta. Clear? That's the formula for deviation, not only for only for two only two reflection it is, right? Lalit is there, nobody else is coming, right? I think it might be late. It's okay, they may watch afterwards also. What, Lalit? Did you inform others? Nishant and others, Ati, um, other students. And by the way, are you writing also? Sam, Lalit, Monish, did you? No, not this. I'm asking about the writing test. Test, are you writing? Did you give the test? No, no, you need to give it, because ray optics basic reflection, last week only you had exam, right? So six papers I created. Six paper I created so that you can 10 questions are there. Last two were hard papers, correct. But first three, four papers were easy papers. Lalit, what about Lalit? Onish, did you write that? Try to write, then only we can know how you are doing, how is your performance increasing or not. Okay, sure, let us go next. Okay, so we got this deviation formula, we got is for two reflection. Then shall we go next topic? Yes. In this, what is the next thing? Next thing is that question can come, how many number of reflection can happen? Maximum. This nobody will tell. It's only for J, and that also in J we have done that. There is a technique for doing that. Okay. That technique we will discuss. Maximum number of reflections. Suppose a ray is coming like this. What is the maximum number of reflection that can happen? Okay. Let us try that result. Maximum, this is second topic in this, maximum number of reflections So consider inclined mirrors at an angle of theta and take for example a ray coming like this. This ray is making, here normal you make, let us say this ray is making some angle I here. This angle I is given. Now the question is that how many maximum reflections can happen? Here one reflection, next, second, third, fourth. How many reflections can happen? How to know that? For this we need to understand a technique of mirroring the mirror. The technique is called mirroring the mirror. The mirror you make inside, take the image of mirror in another mirror. Okay, so this technique we will try to apply. Suppose if this is mirror, first mirror, and this is second mirror. Okay, so this point which we right now we can see here, first point of incidence, point 1 let us take. Now what happens is that reflections which will happen, again here reflection will happen, right? I'll give example first of all, try to understand. Suppose reflection happen one time, it will come here, right? Come here. Now this is the second point where it will be hitting. Okay, second point it will be hitting. Now here if you see that again reflections can happen and all that. So the point 2 image, if you see here in the first mirror, if you see the image of point 2 in the first mirror, the image of point 2 will lie exactly on this point here, 2 dash you can say. So it will lie exactly on this line which you extend it like this. It will exactly lie on this line. Why? Why it will exactly lie on this line? That we need to understand. Exactly it will lie on this. I will extend this line like this. So this point, this image of point 2 will exactly lie here. Why? Because this is symmetricity, whatever angle it is making, the same way. You remember that? I think you remember this. Suppose there is a plane mirror, and if there is an object which is moving like this way, image will also be having like this way, exactly same way. If this angle is theta, this angle is theta, you know that, right? This concept you know. So same thing you assume like this. This is the plane mirror, this is like object, this is image. Exactly it is coming like the symmetricity. So what we can do is actually this entire mirror can be reflected here. So this mirror which we are taking here as a mirror, second mirror can be reflected in this first mirror like this. So now this mirror 2 can be shown here like this. Okay. So mirror 2 has got reflected in mirror 1. Again what will happen? This mirror 1 can be reflected in this mirror. So you try to keep on making mirror after mirror like this, like this, like this, like this, like this. Okay. So remember that these angles, all angles should be same angle as theta, 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 like that. Okay. So these are all the mirrors which are getting reflected, and these points which you can see here, these points are the points where images are formed, or these are the points where reflection is happening. These are the point of reflections. These are the points of reflection. Okay, are you getting this? This technique is a very important. Say advanced level, international Olympiad level. This technique is. It was given in the Pathfinder. No other book had given it. Okay. So, because using this technique, we can make a formula which can be used for the main NEET if it is difficult, or the advanced level. Okay. So try to do. So this is your second reflection. This will be third reflection. This will be fourth reflection. Like that, and number of reflections can keep on happening like this way. Okay, and number of, so what is the maximum value of n? That is what we want to calculate. Maximum value. How do we calculate? Now see, look at this triangle and carefully try to observe. This is I. So this angle is going to be how much? This angle is going to be this angle is going to be 90 minus I. 90 minus I. So this 90 minus I is also going to be same this 90 minus I. Okay, 90 minus I. And let us say all these reflections has happened at somewhere. Let us say this is the nth point it is. So now we can take some angle. Let us say this angle is some angle alpha. This angle is alpha because it will be forming a triangle, right? It is going to form a triangle like this. So look at this triangle. 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 Okay. So in this triangle, if you see, uh, because each of these angles are theta theta, right? Each of these angles are theta theta. So this is theta 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 theta. So how many thetas will be there? First you need to decide it. So between 1 and 2, 1 theta, between 2 and 3, second theta, between 3 and 4, third theta, between 4 and 5, fourth theta. So between n minus 1 and n, let us take this as n minus 1. Between n minus 1 and n, that will be how many thetas? Because between 1 and 2 there is 1 theta, between 2 and 3 this is second theta, between 3 and 4 this is third theta. So between n minus 1 and this will be total n minus 1 theta. So this total angle excluding the first theta, this total angle is n minus 1 theta. Okay, this total angle I am writing here n minus 1 theta. Okay. Now because this is a triangle, so sum of all this angle must be 180 degree. So alpha plus 90 minus I plus n minus 1 into theta, the sum of angle must be 180 degree. Clear? Once you get this idea, then try to solve. What we want from here? We want alpha. We want alpha. What should be the alpha? So try to solve alpha. Try to calculate alpha from here. So alpha will become equal to, take that side. So 180 minus 90 become 90. Minus I will become plus I, right? And this will go that side. It will become minus n minus 1 into theta, right? So we are getting this idea we are getting. Now suppose I want maximum n, maximum number of reflection I want. So as n, I and theta are fixed, I and theta are not changing. So uh, as n increases, alpha will decrease because this term is negative, right? It is increasing, so it will be decreasing. So maximum value you can take as n minus 1. Let us take for alpha. Alpha can be, what can be alpha? Note that alpha is an angle. This angle has to be greater than 0 because you are saying that it is a triangle. Correct? Na? Equality also you can apply, greater than equal to, because it is possible that this line can become 0. This angle alpha can become 0. Is it possible? Because because this is the line and you are making this triangle, so it might be possible that alpha may become 0 but may not be, greater than equal to 0. Let us apply the condition. So 90 plus I minus n minus 1 time theta must be greater than equal to 0. So from here n minus 1 time theta must be less than equal to 90 plus I, right? So from here you can calculate n. So n minus 1, from here it will be 90 plus I divided by theta plus 1 plus 1. So this will be n. Now note that you want, suppose for example this come as 25.3 it comes. So you have to take only 25 because integer you have to take. So this n will be the greatest integer function 90 plus I by theta plus 1. This formula, a very important formula, this is the maximum number of reflection. maximum maximum number of reflection will be given by this formula. And here the square bracket means latest integer function. Don't think this is a ordinary square bracket. This is not a ordinary square bracket. This square bracket means greatest integer function. Greatest integer function. Greatest integer function. Okay. So we can calculate. That means if theta is given and I is given, we will be able to tell how many maximum reflections can happen. Let's take one example to understand this. Suppose if I say that there are two plane mirrors at an angle of 60 degree and there is a ray coming like this. This ray is making an angle of incidence. This angle of incidence is given as, let us say, 30 degree. How many maximum reflections can happen? If this question comes in NEET or JEE Main, only those person who have this formula can solve it. Others cannot. Now, let us try this. So, maximum is equal to, apply this, 90 plus I is 30, divided by 60 plus 1. So, this becomes 120 divided by 6 plus 1. Right? That becomes anyway exact, 3 it becomes. So the answer will be 3. So maximum number of reflections that can be happening is 3 here. Uh, oh, it is 60. So then how much it will be? Correct na? 2 plus 1, 300. Right? I think I made that 0. Okay. So the maximum number of this will be 3 only. Correct. So the total maximum number. Now you may ask here question. Suppose in this question they give misfortune, that is, if they give that find the total deviation after all the reflections, then after all the reflections, because three reflections are happening, now what you will do, because you have formula only for two reflections, correct? Are you understanding the question? See, if they say that find the deviation for two reflections, then 360 degree minus 2 theta you can do, you get the answer. But here if they say find the total deviation after all the reflections, so three reflections happen, we have to figure out now deviation, how to calculate. Hmm. How to calculate? Huh? Deviations, how to calculate? So you need to know the formula for deviation also. Total deviation formula also we need. Suppose 5 reflection, 10 reflection, 2 reflection. We need a formula. We need to derive a formula for deviations happening, right, after n number of reflections. Okay. So let us go back and try to derive a formula for n number of reflections in this mirror. So are you clear about this? This formula, I hope you are clear. Maximum number of reflections we can get. So let us try to find out deviation after n reflections. So applying the same logic little bit, in the same manner we will go for that, and we will take the same approach. We will take dot 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 dot, dot like this, and we will take these reflections of mirror after another, theta 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 theta, like that we will take. We keep on taking all that, right? So now suppose if I take this as the first reflections, already I told that angle of incidence will be given. So this angle I am taking as I with the normal. and this already I have taken as 90 minus I. So if you take this is 90 minus I. Okay. So like that we have to note. So but note that here this deviation, how to calculate deviation at any instance. Deviation formula already we have noted. What is deviation? Deviation formula at one reflection. It is 180 minus 2i, right? 180 minus 2i, that is the formula. 180 minus 2i. Or you can say, see 180 minus 2i, that is deflection for one place, 180 minus 2i. That can also be written as 2 times of 90 minus I. Right. So if there is a mirror and if a ray is coming and it is getting reflected, so this is I, this is I. This angle is 90 minus I. This angle is also 90 minus I. And if you extend this ray, so this angle also become 90 minus I. So this 2 times of 90 minus I, that is what is deviation. That's what is deviation, right? So deviation can be, and this angle is also called glance angle. So this 2 times of glance angle you can say, theta glance. Glance angle is the angle made by the ray with the mirror. So mirror it is making 90 minus I is the angle made with the normal. So, so with the mirror what angle it is making, that is what is important. So this ray will be making these angles, right? So we want to calculate these angles with the mirror. Okay. So like this ray was making angle 90 minus I. So then can we calculate similarly what will be this angle, because this is theta. So this angle becomes 90 minus I plus theta, right? Again this is theta, again that is same angle. So extra theta you have to keep on adding. So I am writing glance angle here. At the first place glance angle is 90 minus I, next 90 minus I plus theta, then next 90 minus I plus 2 theta, like that it will come. Okay. So here glance angle will be 90 minus I plus 2 theta. Similarly here this glance angle will be 90 minus I plus 3 theta. Like this glance angle will keep on happening. Clear? So this glance angle, if you multiply by 2 times, you will be getting deviation at all the places. So total deviation you can calculate as first place deviation, second reflection deviation. Like that, suppose n reflections are happening, so you have to take for all the deviation. And deviation at one surface is 2 times glance angle. Here glance angle is 90 minus I. Next glance angle is 90 minus I plus theta. Next glance angle is like that, it will continue. For next last one will be 2 times 90 minus I plus, you see for second one it is theta, so it is nth one will be n minus 1 into theta. Okay, like this we can calculate the total deviation. Let us add this, some arithmetic progression will come. So if you try to get an arithmetic progression, what it is, you want, you can open this and take 2 common. So 290 minus I will take common. So 290 minus I, 290 minus I, 290 minus I, starting from here to up to n minus 1 term. So this is like the 0th term, then like that. So how many times it will come? That will be coming nth time. Check that. Check this. N minus, because it is starting from here, then first theta it is coming, then up to n minus 1. So from here to here n minus 1 terms are there, and this is extra term, so it is total n terms are there. Okay, that you will do. Then here there is no theta, then here will be 2 theta, 2 theta, like that it will. 2 if you want to take common, 2 if you want, let's take common. 2 you take common. So this will be theta plus next also extra theta will be coming, right? 2 theta will come. Then next it will continue like that up to n minus 1 times theta will be there. Now try to add this. So this will be 2 times 90 minus I times n plus here take theta common, so this will become an arithmetic progression up to n minus 1. Last term is n minus 1. So tell me what it will be. 2 times of 90 minus I times n plus plus. This is sum of natural number. So n plus 1, so this will become n minus 1 plus 1 by 2. Right? So let us now solve it. So this will become 2 times of 90 minus I times n plus, here this will become n, so n theta by 2, and it is n minus 1. So now if you want you can take even this n also common. So let us take 2n common. So 2n if I take common, it is 90 minus I here, and I have taken common, plus theta by 2, and this is n minus 1. This is the formula for deviation, total deviation, net deviation for n reflections. For n reflections. Okay, let us try this formula. This is a very important formula. To n 90 minus I. 90 minus I is the first glance angle. If you want, you can write like that. So let us try this for this portion and see whether this formula is correct or not. So we have taken this angle as 60 degree. If you remember, here normal was there, incident ray was making an angle of 30 degree. I want to calculate for two reflections and check whether this formula is, because for two reflection I know 360 degree minus 2 theta, I can get the answer. 360 minus 2 theta means what? 360 minus 120. 360 minus 120 is 240. So for two reflection angle should come 240. Let us check that. Take the value of n as 2 and check here. Division for two reflections. So 2 into 2, 90 minus I is here 30, plus theta which is 60 by 2, and n minus 1, 2 minus 1. This is 4. 90 minus 30 is 60, plus this is becoming 1, 1 will get cancelled, half it is coming, 1 by 2, so this is becoming 30. 4 into 60 plus 30, 90, 90 into 4, 360 degree it is coming. For two reflections it is coming like this. Is this correct or not? Because we know for two reflections formula, 360 degree minus 2 theta. So 360 degree minus 2 into 60, that become 120, so 240 degree answer should come. Why this answer is not given? That. Did we substitute correctly? 2 into 2, 2 into 2, 90 minus I, 90 minus 30, plus theta by 2, 60 by 2, n minus 1, 2 minus 1. So 2 into 2, 4, 90 minus 30, 60. 90 minus 30, 60, plus 60 by 2, 30, 30 into 1. It's not showing here. It's not coming. Suppose if you take three reflections here, check what it is giving. Three reflections if I put, and it's equal to 3, then what it will be happening? Deviation will be 2 into 3, 90 minus 30, plus theta by 2, 60 by 2, 3 minus 1. Check out this. 6, this become 60, plus this become 30 into 2. So that becomes 6 into, this becomes 60 plus 60, 120. So 6 into 120, it becomes 720. It's in complete rotation. We will check this formula whether this is correct or not, but derivation is the same approach. Same approach we derive. Okay. Because the glance angle that is happening at this place, right? That's what. Suppose if you take one reflection and check one reflection, what is it? For one reflection also you check this one. One, if I put so 2 into 90 minus 90 minus 30, that becomes 60. 60, and this becomes this 110 only becomes. So this becomes 60. 60 into 2 is showing 120 degree, correct? 2 and into this is showing 60. 60 into 2, 60 into 2 it is showing 120. So I think somewhere some mistake has happened because uh, 180 minus 2 theta, that is showing correct. 180 minus 2 to 120. For one reflection this formula is giving correct. For second reflection it is not giving correct because for second reflection we have 360 minus 2 theta formula, correct? Or did I make anywhere mistake? Tell me. 360 minus 2 theta 120, 360 minus 120, 240 should come, but it is not coming. 2 into 2, right? 2 minus 1, 1. Correct. It is giving 360 degrees. So where has been the problem? So I think we need to check the derivations. What we have checked is the same place here also, like this way. Glance angle is this only, I think. This ray is coming and with this mirror it is making. Is the calculation correct? Because this is I, this is 90 minus I, this is also 90 minus I, and this is also theta. This become 90 minus I plus theta, right? And then this is also theta, this is 90 minus I plus 2 theta, like that 90 minus I plus 3 theta. So like that we are doing it, correct? Yes. Are you able to see that? 90 minus I plus 2 times 90 minus I plus theta, like that 90 minus I plus n minus 1 theta. Is there any mistake in this happen? 2, I have taken common, 90 minus I has come. So 90 minus I, so this will be going for starting from here to n minus 1. So n times is there. Then this is coming as theta, next 2 theta up to n minus 1 theta. So is there any mistake in this? I think no mistake is there. Right? So 2 times 90 minus I plus theta, 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 and minus 1 time. Theta we have taken 1 plus theta and minus 1 terms. Then this is sum of numbers. So first term plus last term divided by 2. Is it correct? Or did I make a mistake here? Sum of n terms. What is sum of n terms formula? First term plus last term divided by 2. Might be I have made mistake here. Tell me. Sum of first natural numbers n into n plus n into first term plus last term divided by 2. Yes, Sam, Lalit, check this. Is this correct? N into n plus 1 by 2. So n is here n minus 1. It is going from 1 to n minus 1. So this is n into n plus 1 by 2. Correct only now. Right now. This is number of turns is n minus 1 here. So number of turns is n minus 1 and plus 1 by 2. Here n by 2 factor was coming. So n by 2 theta n minus 1. Right? That's what we have got. Okay. So I have also taken an outside. So 90 minus I plus theta by 2 n minus. Absolutely correct. There doesn't seem to be any fault here. Okay. But maybe we'll check afterwards. But technically it should happen. But see, the problem is that sometimes what happens is that The clockwise anti-clockwise also matters. I think this is where mistake can happen. Clockwise anti-clockwise, because see, first example, deviations, how clockwise anti-clockwise we need to do that. Suppose for example here, if a ray of light is coming like this way, okay, and let us say deviation happened like this way. So the deviation that has happened, it has happened in anti-clockwise. Then suppose for example here deviation happens, so this deviation has happened again in anti-clockwise. So these deviations we will simply add because they are going in the same circle, anti-clockwise they are going, so we have to add them. But are we sure that these deviations we have to add or subtract? Right? Correct. Yes. That might be problem here. We have simply added them, but we do not know whether that deviation is going to be uh, like um, like are the deviation going to be all in the same way or in other way? We do not know. So how to check them? How to check it? So I think we need some technique to check that. Anyway, uh, because for example here the glance angles that we were calculating, right? How are we taking glance angles? Glance angle we were taking it like this, right? We are taking first glance angle as 90 minus I, next is 90. I think here only this problem is happening. It should not be more than 90 degrees. That is the idea. Glance angle should not be more than 90 degree, because glance angle is angle made with the mirror, angle made with the mirror. So if it is getting more than 180 degree, then we need to subtract it. I think there is where a mistake has happened. We are simply adding, because this 90 minus I is smaller than that, so 2 into that it's okay, but 90 minus I plus theta it can become, you check that the second how much it is coming. So let me check that. Okay, maybe we can directly apply this approach. Maybe I think this approach will be better. You take deviation, calculate deviation 1, calculate deviation 2, calculate deviation 3. So first deviation will be calculated as 2 times 90 minus I. So it has come 2 times 90 minus I, here is 30, right? So 2 times 60, which is 120. Okay, next time, if it is 2 times 90 minus I plus theta, so theta already we know, right? So theta already we know as 60 degrees. So 90 minus 30 plus 60, how much? It should not be more than 90 degree. Okay, that means I am talking about this one. Okay, 90 minus I, this excluding the 2, this part. How much it is coming? Check out. It is coming more, na? More it is coming. So 2 minus 30, it becomes 60. 120 it is becoming. Correct, na? 120 it is becoming. Hmm. So I think that is where it is. So what should we take then in this case? Deviation, what should we take? So how much more it is than 90 degree? It is 30 more, right? It is more than that. So what should we do? So 120, we should not take it as 120. Uh, 120 we should not take it, because it cannot make 90 minus 120 angle is not possible. So where have we made mistakes? So suppose if this is, so if ray is coming, if this is 120, this cannot be taken as glance angle. Glance angle should be taken as this one. So we have to take 180. That means 60 we need to choose as glance angle. So if it is coming 120, we have to make as 180 minus 120, which means 60 we need to choose. Suppose I choose instead of 120 here as 60. So 2 into 60 will give 120. Now I think it will come 120 plus 120 240. Oh, that is the technique. Okay, okay. So we need to correct that last time. Here also when we take 90 minus I plus 2 theta for the third reflection, so it becomes 90 minus 30 plus 2 into 60, 120. Hmm. So take this, how much it is coming now? How much it will come? So 2 times how much it will come? 90 minus 30. 90 minus 30 how much? 60. 60 plus 120 it is coming 180. So I think here what is happening? 180, it should be written as 180 minus 80. 180. So this we should write as 0. So that means 0. So the final total deviation in the third case, it is coming as 0. So total deviation, net deviation should be written as deviation 1 plus deviation 2 plus deviation 3. I think this is the algorithm that we have to follow. 120 plus 120 plus 0. 120 plus 120 plus 0. So that we have to give us 240. Okay, by the way, this is going to give us the same answer. Okay, are you getting this? Yes. So I think we need to subtract 180 in this other places. Okay. So that I think we have to manually check it. So that formula is limited that we are making. Okay. Definitely it is limited. So here we need to make sure if it is coming more than 180, then you subtract it. Subtract it, then we will write at 180 minus 120, which is 60. Then we calculate 120. Here also it is coming 180. It is more than that. So we need to subtract 180 minus 180 0. So that means in the third reflection there is nothing happening. No deviation is happening. No deviation happens. It is just grazing. It is just grazing the surface. That's what happens. It is just grazing that. Clear? Are you clear about this? Yes, that's a very important result. It is. Now, here also there is one very important result of that retracting the path. The ray which is hitting is going to retract the path. Let us try to apply this concept of retracting the path. So, retracting the path is a very important concept. Many questions comes on that. Retracting, retracting the path. So same technique we will see. Retracting the path means what? Suppose this mirror is there and this is coming here, like I am now drawing it a straight line. So we are just taking this is theta, theta, theta like that. So retracting means suppose it is going to retract it. Suppose this angle is, all these angles are theta, 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 theta. Suppose this is the first point, this is the second point, this is the third point, and let us say nth point. At nth point, retraction happen. Retraction happen means what? Retraction happen means it must be hitting at 90 degrees. So this angle with the mirror become 90 degree. So that angle become 90 degree. That is what it is. So this angle become 90 degree here. That is the condition for retracting the path. So if you consider here between 1 and 2, this is theta, between 2 and 3, the total angle between 1 and 3, 2 theta will happen. So between 1 and, so this total angle is n minus 1 theta, n minus 1 times theta. And this angle already we have taken, this is I here, this is 90 minus I, so this is 90 minus I. Okay, so now let us add total angle. So 90 minus I plus 90 plus n minus 1 times theta. This must be 180 degree. Now calculate this. So this 90 get cancelled. N minus 1 times theta minus I is equal to 0. Correct? That's what it is. So 90 minus I, this 90, 90, 180. So minus I and minus 1. Correct. So from here we are getting this condition n minus 1 into theta is equal to I. Okay, so suppose they say that what should be this angle I, so that after second reflection, after third reflection, this retraces this path. So this is the formula for this. Okay, this is the formula for this I. Very important conditions. So suppose there is a ray coming and it is going to hit it, no? And they may ask that after fourth reflection, the ray retraces. And note here, this is the number n represent here what? N represent number of point of incidence. Here n represent number of point of incidences. Point of incidences. I will give with a very related example here. Suppose if you take for example that this angle is theta and a ray of light is coming like this way. This ray of light, let us say, hits at this place, and then it comes here and it falls at 90 degree here. So if it falls at 90 degree, it will retrace its path like this way. It will go back, will go back. This is called retracing the path. Okay, so it is falling at the second point of incidence, it is falling at 90 degree. Now suppose if they ask that how many reflection happens, how many reflections, how many reflections happen, then what will be your answer? We know that there are 2 point of incidences, but how many reflection happen? Can you tell? Sham, Lalit, Monish, how many reflections has happened? Hmm? Think about and tell. See, again I will repeat you. Just look at here. So suppose ray of light came and it has hit here. After hitting it gone there. So it has hit now second time here. But now when it is returning backward, it is hitting here the third time. Third time it is hitting. Understood? So how many reflection happen? Three reflection happen. One, two, and three. This is where you will make mistake. In it, these questions come. Some many times it has came. They say that suppose 2 point of incidences are there. It has retracted at second reflection, but total number of reflections will be three because while returning also it is hitting other points. Okay, so what you need to count here is suppose there are two reflections are there. So how many number of reflections we should take? Should we take just n plus 1? What do you think? Let us say, carry one more example. Let us say here also it is retracting here at third place. So 1, 2, 3, 4, 5. Correct, na? 1, 2, 3. After 3, 4, 5. Well, because returning 2 time extra, it will go. So if there are 2 only, so there will be 1 extra. If there are 3, then there will be 2 extra. If there will be 4, then there will be 3 extras. So are we writing this formula 2n minus 1? Just check that. Suppose if I put n as 2, so 2 to 4 minus 1, 3 reflection. If I take 3, so 3 into 2, 6 minus 1. I think that formula is fitting there. Correct? Na? That is what it is. So number of reflections will be calculated by this formula. This formula will give number of reflections. N is the number of point of incidences. Okay, you can check it for any case. Yes, that's what it is. Okay. So I think we are done with this plane mirrors. Then coming to this idea of number of images. Last point here, number of images we have to calculate. So suppose there are two plane mirrors are there at an angle of theta. So this is one plane mirror and this is another plane mirror, and this angle is theta between them. This is first mirror and second mirror. And let us say object is somewhere here. Okay. So you first of all join this object like this, and let us say that this angle is alpha and beta. So what happens to that? First image is formed here in the first mirror. Let us say this is first image, then image is formed here in this second. I2. So note here that when you will make symmetricity, this angle will be also beta. Due to symmetricity, this angle is also alpha. Okay. Let us call this as I1 dash. I1 dash. I1 dash means first image in the second mirror. Similarly, this image I1 which is formed here, it will reflect in the second mirror. This image will act as a object for second mirror, so it will reflect here and it will be coming here. So let us call this as I2 dash. Similarly, this I1 dash will act as a object for first mirror and it will reflect and it will form here. This will be I2. Okay. So again, what will be the angles if you are looking for the angles? So if you see with this mirror, this was making how much angle? This first one is making, this total is theta. This is forming alpha plus theta. Alpha plus theta. So same way this will be making alpha plus theta here also. Similarly, this image is forming theta plus beta. So this image will be making here theta plus beta. So by symmetry, we will apply this method. M1, M2 will tie and we write alpha and beta. So alpha beta represent the images. Alpha represent first image, beta represent first image in second mirror, right? So this represent first image form in first mirror. This represent first image form in second mirror. Then we will keep on adding. This technique is very useful. So keep on adding theta. So alpha plus theta, beta plus theta. Then again keep on adding theta. So alpha plus theta if you do. So plus 2 theta. Here also beta plus 2 theta. Like that keep on happening. But note that suppose the final term is there. Final term. The final term either here or here. Final term. So this final term or the final angle that we are getting, it must be less than 180 degree. That is the most important thing. So final term, this is a condition. Final term must be less than 180 degree, right? And second thing is that if the final term of this one plus final term of this one, okay, so sum of these angles if you do, final term is this one for the first one and second one, sum of these two terms, right, plus the angle theta if it is coming as equal to 360 degree. If this come as 360 degree, then then final images coincide. Then final images coincide. Final images coincide. Coincide. Okay. So this is the approach to calculate the number of images. I will give one example for this, one or two examples. Then we will be winding up this today's session. Okay. Reflection will continue in the next class. Let us take one example here. Suppose that this angle is, let us say for example, this angle is 72 degree, and there is a point here which is making 50 degree, and let us consider this as some angle with it. Let us take this is 50 degree and that is 22 degree. Okay, right? Some object is kept. They will ask how many images are formed. How many images are formed? Let us say this is first mirror, this is second mirror. So what you will do? You will do this technique, you will apply. This is 22 here and this is 50 degree here. Now keep on adding 72. Add 72 here. So that will become 4 and 94. Add 72 here. 2 and 7 plus 5. 7 plus 5 is 12, 122 degree. Again keep on adding 72. Add 72. So 122 plus 72 is becoming 194 plus 72, so 6, 9 plus 7, 16. After that if you add, definitely it will be greater than, right, 180. So we cannot take that one, so we should not count this one and neither we should count this one. So how many images are formed? 1, 2, 3, 4, 5. These are the 5 images which are formed, and the number of images is 5. This is the answer. Did you get that? This is the technique. Now here there is also a formula given in textbooks where we write like this. We need to check 360 degree by theta. So 360 degree by, let us say it is coming as E1. Then number of images is given as 360 degree by theta minus 1. Okay. So this formula is used. Another case is that 360 by theta is odd. 360 degree by theta is odd. But object is kept symmetrically. But object kept symmetrically. Object kept symmetrically. Object kept symmetrically. If object is kept symmetrically, because of symmetry, number of images coincide. So the number of image formula will be same. Number of images formula will be same as 360 degree by theta minus 1. Okay. So this is the case of symmetricity. So symmetricity happen because of two reasons. One is that this 360 by theta is even, and another is although 360 by theta is odd, but the object is kept symmetric. So due to symmetricity, the formula is only the same, 360 by theta minus 1, 360 by theta minus 1. But suppose 360 degree by theta is coming as odd, and object is kept unsymmetrically. Object is kept unsymmetrically. Then in that case only the number of images formula will be 360 degree by theta. That's the only case we will apply this. Clear? But the problem is that suppose this does not come as even odd, it comes as fraction. Suppose it comes as fraction, then you cannot do anything. Then you must solve by this approach. You must apply this approach. You cannot go by any other approach. That's why this is the most fundamental approach we have to apply, and it doesn't take much time. Okay, it converges. The solution comes after a few steps only here. So better you can go with this approach if, and the 360 by theta is coming as fraction. Suppose 360 by theta comes as 10.87. What you will do? Will you take even or odd? You will be confused. So better you go by this approach. Here you will be able to figure out exactly how many images are forming and in which mirror how many images are forming. Right? Are you clear about this? Yes? Yes. So this is a very important topic. I think we have covered that. A plane mirror incline was, I think we may previously we left out, but today we have covered that. And previous class we have covered the mirrors, spherical mirrors. Velocity and other things, right? So now I think we will be able to work out and keep working out problems. Then we will continue next class. Right? Sam, okay. Monish, Lalit, bye bye. Good night, mom.